All right, guys, so this is my shop. It's a 20-foot wide by 30-foot long box. It is cinder block constructed, and it's been getting pretty cold in here. Let's see, I think it's 37 degrees in here right now. Yeah, it's pretty cold in here for working in one area, not really moving around too much. It has 12-foot high ceilings. And as you can see up in this corner right here, it has a old oil burner. It used regular home heating oil, and it hasn't been used in a long time. There's a lot of components missing. Somebody's been dicking around with it, and I just don't want to deal with having to figure out what's wrong with it, get it up and running. As you can see, it's not attached to the chimney anymore. So what I've decided to do is I'm going to build a waste oil burner. So I have some pieces here. I scavenged this blower right there, you see, with the motor out of that furnace in the ceiling. I have some HVAC ductwork, some other components here. This probably looks familiar. This is a drip window for the drip feed. It's going to be a gravity drip feed oil burner. Some flue collars, some mesh for a guard over the motor because it has a separate motor, as you can see. It attaches to the back of it, so I'm going to put a guard over it. I scavenged a couple doors. We have this is a barrel kit. This is a door off of a old Ethel wood stove, and then we have another one. I actually saved that just for this build because I wanted to have the window. It's not the greatest condition, but you know, it allows me to see the flame. And for my reservoir, I have this old propane tank. This is off of a forklift, fork truck, whatever you want to call it. I've already cut the top off, plugged up the other holes, and you know, just in case anybody decides to use any of these for anything, make sure you put a little water in it before you start cutting into it, just to be a little safe. So yeah, I'll be using a 275-gallon oil tank that actually used to feed the furnace that's in my ceiling. I'm going to cut it down to about 2 feet long, maintain the same height, and we'll see how it works. I mean, I don't know how much BTUs I need. I'm going to run a calculator and get an idea of how many BTUs I need. There's no way for me to determine how I'm going to build it to have that amount of BTUs. I can only build it and gauge it after it's up and running and working. So let's get down to it. I won't be doing any sort of time lapses. I'm just going to do this as a step-by-step process. And every time I complete a step, we'll go over what I've done, and I'll show you what I'm working on and what comes next. So let's jump into it. All right, so this is the oil tank that was feeding the furnace in the ceiling in my garage originally. I tore it out. Yes, it is upside down. It's a standard 275-gallon. It's in pretty good shape, just has some flaking paint on it, a little bit of surface rust, but nothing that can't be cleaned up. So the first thing I have to do is just grind down these welds right here, and these caps will just pop right out, and I can cut it down to length. Okay, so I'm just taking a second to show you what I'm doing. I got this end cap off. I obviously cut it off one end, and I cut this down to 24 inches. So on the bottom here, it's open. The other end cap is still on. I made my template for my heat exchanger tubes right there, and I laid my door out just to see where it's going to land. And to get the heat exchanger holes exactly in the same spot on each end cap, I'm going to take this cap and slide it right inside up against the other one, and then just drill my pilot holes. And that way there, when I put the heat exchanger tubes in, they should be lined up pretty close, because this cap, when it goes inside the barrel, it's within probably a 1/16 of an inch. So I'm going to get that done, and we'll see how it comes out. So I'm at the point where I'm working on the wood stove door attachment. I have the heat exchanger tube holes cut out. The other side's right over there. Now, if you were using one of these, it's very easy to use a barrel stove door kit, because you just trace this outline, trace the hole, cut the hole out, drill the holes for the screws, and attach it. I would recommend using a little bit of furnace cement on this surface just to get a better seal. Now, if you're going to use like a flat door like I have that's much wider, this surface right here is not perfectly flat. They bow out, so you have to box it in. So I took the wood stove door, all apart, took the gaskets out. This is the gasket to seal the door. This is the gasket for the glass. And all I did was take some bar stock, some 1/8 inch bar stock like this. Let me just show you here. Just 1/8 inch bar stock. And I took long strips of it, spaced it out so that it would land right in the center. And I made a gasket sealing surface like this one. You just kind of have to brace it when you weld it together inside the door so that when you take it out it doesn't lose its shape. And I used some old bed rail angle stock and just boxed it. So the idea here is that we can take this, trace it onto the door, cut the hole out and get a nice snug fit, slide it in just a little bit, weld it, and attach the door. So once the door is on, I'm going to work on getting the legs on. I cut them all to the same length. I just got to square them up, weld them on, and then I can stand up the barrel and start working on the burn chamber. So I'm setting up to divide the chamber. Basically, I'm putting in another floor. This is how I'm doing it. You may want to do it a different way. Right here, this piece of stock simulates the panel that's going in, so it gives me an idea of where I want it to land. This is just a scrap piece of angle stock. I cut 2 pieces that are the same length, and I obviously leveled it out. There is a 1 inch gap at the end here, and I did that on purpose because on the front there's a 1/2 inch gap around the lip. So what I'm going to end up doing is I'm going to cut a few slices of this and mark, every foot or so around the edge so that when I put the cap on, it'll kind of have a stop. And when it's all said and done, this 1 inch gap here will actually turn into 1/2 inch. And the flange, just like on the front, has exactly a 1/2 inch gap. So once I get these rails tacked in, I can start making the floor. But I just wanted to show how I was doing it. Magnets are a big help and a level. So let's get to it. Here are the rails to hold the divider panel, all square and level. And the tabs, I welded the tabs in. There's one on the bottom, and there's a couple at the sides. And those are just to stop the back panel from going all the way in, and to keep it nice and even. It came out pretty good. It has a lip, just like the front. And any gaps that it may have, which it does have some, you can see the light shining through, you can easily take them up because it's kind of flexible. And I test fitted one of the heat exchanger tubes. It's nice and straight, fits good. So now I'm going to work on the divider panel and the burner pot. So here's the divider panel that I put in. This is just another piece of the tank that I cut off, the flattest portion I could find. And as you can see, it is 2 pieces that are welded together. Now, when I slid it in, it was obviously squared off, and this is a round edge here. So a good tool to have is a profiler. As you can see, I just used the profiler, and it makes it fit together kind of like a puzzle. And it's pretty tight. There's only about a eighth of an inch gap there, maybe. Now, I could still use this panel even though it's not perfectly flat because it has that flange, because I'm using a very large burner in mine. Now, this is the air tube for my burner pot that passes through the metal. So as you can see, it actually will pass through the flat portion and still be pretty centered in the stove. So I may just weld a piece of scrap steel like right there just to kind of catch the pot so that it doesn't rock, and this will be the center tube that passes through the bottom of the floor. And it is a little warped, but as you can see, this stuff is pretty easy to manipulate. So the profiler tool is a must-have, especially when you're trying to get nice tight gaps. Okay, so I'm building the burner pot now. This is the size I decided to build based on the dimensions of other burner pots I saw in other YouTube videos. I don't know if it's going to be too big or too small. I'm not really sure yet. I can make adjustments to it if I have to. Pretty simple. It's only tack welded right now because I wanted to take a minute to show you how I put it together. So I just basically started with a hexagon, that's got 3-inch sides, and I used 3-inch wide plate that's 3/16 thick. As you can see, it's, you know, it's the same, each side is the same width as the plate. And as I put it together, I had the pieces to finish it, essentially. So this is the main air intake tube. This is the sides of it, the ring, I guess you could call it. And that's the floor. It's still in pieces. Pretty easy to put together. Try to not waste the scrap because I still have to make other things with that bar stock. And you know, as I took pieces out, I could fit it to other portions that I needed it for. I still have to drill the holes in the intake tube and weld the whole thing together. Once this floor is welded together, I'm just going to prop it up on some of these lug nuts that I have to give it that gap that it needs to make like a flange so they can slide through the floor. A pretty simple design. Most of these are designed the same way on YouTube. Jerry's DIY, got to give a shout out to that guy. He's done a lot of research on these and a lot of trial and error. So we're going to try his design and we'll see how it works. Here we have the bottom of the divider panel that I'm working on. And this is where my heater will differ than a lot of the other heaters you'll see on YouTube. So because the furnace blower that I have for this stove is very oversized, it's going to put out a lot of air. I've decided to leach off that air and add a duct system to the bottom of my burner pot. So this is just a simple duct that I'm putting together on the bottom of the divider panel. Very simple, made from scrap from the oil tank. I haven't put it together yet. So that's where the burner pot will slide through, and the air will come in this way and kind of force a nice, efficient, clean, and hot burn. So that's what I'm working on right now. This is the intake. This is that intake duct that I was working on. It's kind of all set in place. It's not welded yet. Big helping hand here is a jack strap, a ratcheting strap, and some weight, as you can see. So now I just have to cut the top piece of the panel, of the back panel. I'm just gonna notch it for the intake duct. It only needs to be notched like maybe 1/4 of an inch around that square. And I can start welding up everything, and it's almost complete. I just need to build the manifold for the back for the blower and then run the duct work down to my intake. I got the back piece on. This is the top panel. Now I really didn't want to cut it in 2 pieces like I did there, but I kind of had to with the duct work. So everything's fit in place. The back piece is tacked on. It just needs to be all welded up and I can start building the manifold. You can see the lines that I had ground down here. Started cleaning up the back to attach the manifold that the blower is going to attach to. So once I get that all that done, I'll cut back to the video and show you what's going on again. Working on the manifold, plenum, whatever you want to call it. It's basically just a box, can be any shape. It's this shape because I'm using pieces from the oil tank. The idea behind the plenum is that the blower will attach to a flat surface here and it will force air into this box and it will force air through the tubes at a higher velocity. It kind of builds up a little bit of pressure here. Right now I'm working on the damper as well. Now my air intake damper, there's going to be a duct that comes down here and enters into this intake tube. Now I don't know if this intake tube is too big or too small. This is a 3-inch by 7-inch hole. So I want to make a damper that will slide open this way, allowing me to adjust how much air it gets. Hopefully it's enough. I hope to only have to open it halfway, maybe 3/4 of the way, but whatever works. So over here, I'm working on that damper. Very simple in design. Just a couple pieces of angle iron from a bed frame and a piece of 3/16 plate. And the idea is that this will slide open to expose the 3-inch by 7-inch hole that I have to put into it. So as soon as that's done, we'll see how it goes. This is the sliding damper that I made. It's the first one I've ever made. Came out pretty good. made from all scrap. These are pieces of bed rail. This is a new piece of 3/16 plate, a little small piece here too. To get the spacing, I just put a couple 1/16 inch washers underneath it, laid the plate on top, welded it. I did mark it as well. When I slide it out, it's got notches, 25, 50, 75%, and it has a little stop on it, just a tack weld to hold it. It slides pretty good. Just gonna put it in line up here. Put it right in line there, and that's gonna be my intake. All right, get to a point where I'm now mocking up the blower on the back. You can see that my intake chamber in the back with the slide damper is all done. Don't mind my welds, this is very dirty metal. Probably grind it all up to make it look better. So this is the slide damper that allows air into this chamber. I'm gonna see how that works. Hopefully it works good. And right now I'm just mocking up the blower on the back. I'm building the frame. Just gotta tack some of these pieces of angle stock together, take it off, weld it all up, and then just patch in these holes with some more of the scrap from the oil tank, stand up, and yeah, start wiring the blower up, building the reservoir. So it's coming right along. Here we are, all welded up and in place in the corner. I'll give some quick dimensions here. So from the face to the back of the blower, it's 5 feet long. It remains the same width, 27 inches wide. And the height from the floor to the flue is 50 inches. The interior dimensions of the burn box, it's 28 inches high, 24 inches long, and 27 inches wide. I'm using a 6-inch flue and 2-inch ID pipes. The manifold that I built on the back to help the blower build up a little bit of pressure is 7 inches long, 23 inches wide, and 20 inches high. And then of course we have the slide damper down here that I made for the air inlet. And the air inlet size is 3 inches by 7 inches. So not too bad, it's not too big. In comparison to the old furnace, which obviously it doesn't take up floor space, but it is pretty big. This is about probably half the size of that. So I'm gonna start working on the reservoir next. Okay, here is the reservoir all set up with the drip feed. The blower's all wired up, it's on a switch. I'll show you the reservoir. So this reservoir is a propane tank from a fork truck, flips upside down, so the fittings are on the bottom. I cut the bottom of it, and now that's now the top. We'll start from the top. This pipe right here that's sticking out, this is where the oil goes in. It's actually off the floor, off the bottom of it, a couple inches. This is so it doesn't pick up sediment or water or anything else like that, sludge. The only other open hole is this one, and that's for the drain out right here on that valve. So I can drain water, sludge, clean it out, whatever. The first gate valve here on the feed is just the on-off switch, basically. And it comes down to this second gate valve, and this is to control the flow. It's all 1/2-inch copper piping, and it does slide into this T-piece. You can see it sticking out right there. That's just so the oil doesn't spin around inside the pipes. So we'll have a nice drip right there. And that just drips all the way through into that 3/4 inch pipe that I slash cut. Just kind of wanted to be able to see it again, I guess. I don't know. It's just the way I made it. That goes over here through the wall, down that pipe, and right into my burn pot. And as you can see, I did fire it. I used some kerosene just to see how it worked. The fire brick I just had around, so I just threw it in here for now. I may actually line the bottom and the sides with it. I'm not sure yet. We'll see how it works without it. The blower is now all wired up. It works great, and it's quiet. It's actually very, very quiet. And it throws out a good amount of air. This air comes out of these tubes probably 15, almost 20 feet away. You can feel it. I don't have an adjustment on the speed or how much it comes out, but you know, it works great. So I'm literally just waiting on the pipe. It's on the FedEx truck, so hopefully I can get this finished up today and finish up this video. So it's finally complete. I have the stovepipe installed, goes up to the old flue in the ceiling for the old furnace. I changed up my drip feed so that it's just a pipe that goes directly into the pot. There's nothing in the way, it just drips right in there. Right now it's actually burning about 2 liters per hour, so 1 gallon will last 2 hours, which is pretty good. And I get about 15 to 20 degrees out of it per hour. If I turn the fuel up, it will go much higher than that, probably 30 degrees an hour, which is pretty good. So I'm gonna start it up now. I'm just gonna use some regular kerosene. It's 1K clear kerosene. It lights, it will usually go right up. A little more air. So I'll usually let it go for about a minute or so, and then I'll start adding oil. Gotta get the pot nice and hot so that the oil will vaporize. I'm gonna start it just real slow, because if you feed it too much, it'll actually put the fire out, because the oil is very cold and it'll cool down the pot. So I'm just gonna start it at a little bit of a drip like that, and then I'll give it a very slight stream after it starts to go. I can hear it crackling, so it's starting to boil. Give it wide open air. So that stream right there is probably just under 2 liters per hour. I should be going. It's a very small flame. So it's about the size of a pellet stove right now with that oil drip on it, and it'll keep going. So I'm gonna increase the oil now to get a bigger flame, obviously more heat. You have to do it slowly, otherwise you put the fire out. Here it is about 5 or 6 minutes in. You can see the flame is significantly larger. I've added a little bit more oil. Burns very, very clean. This is the drip I have going on right now. some temperatures. So on the tank, around 350. Bottom pipe's always the hottest. So between 250 and 300 on the pipes. When I had first started the stove, it was, I think it was 30 degrees in here. So right now we're right around 41. So a little less than 10 minutes, I gained 10 degrees. So it's working really well. And again, that's all about how much fuel I'm giving it too. Here's the flue. As you can see, there's no smoke coming out. You can just see the heat radiating out of it. Perfectly clean. You'd never even know that there was oil burning in there. And this is about 15 minutes in. So we got some temperatures right around 500 degrees on the tank surface itself. Pipes are sitting around 500, probably a little less as you go up, yeah. So it works great. The lowest drip, if I drip it, this is the lowest. So if I start to close this valve just a little bit, it'll start to drip. Just a hair. These gate valves are kind of a pain to adjust. So there's just a drip. And if I just open it just enough to get a tiny little stream out of it. Right there. That is literally, I want to say a gallon of oil right there on that stream it'll last 3, maybe even 3.5 hours. And it will just help maintain the temperature. So this is a very set it and forget it type of build. I mean, it's ultra efficient. And I honestly, I think it's because it's a forced air system. So, you know, in the back I have the blower that feeds the air tubes, and then I just made this damper, and I'm gonna try and get a better shot of it. I mean, so you can see what's going on back here. But you can see that the plenum is attached to that damper, and this just controls the air. I leave it wide open all the time because it burns it the cleanest and the most efficient. And it's great, it works awesome. And this motor I'm using to drive this blower, this is a single phase 3 amp. It doesn't have a capacitor, it's a shaded pole type. I don't know if that has anything to do with it, but by my calculations, I did the math at 11 cents per kilowatt hour. So if I run this thing for 8 hours in a day, it's probably gonna cost me about $1.50, maybe $2 with all the service fees and whatnot added on. So, you know, if I ran this thing each weekend day, I might be looking at $4 or $5 for the whole weekend just for electricity to run it. The heat coming out of it is great. And well, I hope you enjoyed my video. This is my first waste oil burner, and I have to take a minute to thank Jerry's DIY. Jerry's a really nice guy, and he's done a lot of the trial and error of this. I used his burner pot design with my own twist on it. And yeah, good luck out there, and if you decide to build one, be careful, be safe, and thanks for watching.